All right, last video was on just kind of an introduction to moles. This is going to be on how to do some math with moles. And I tell you, there's unfortunately a lot of math involved in chemistry with this mole stuff, and it's pretty much the rest of the year. So something you got to kind of figure out. It's pretty doable. I always use dimensional analysis for everything. So everything I do will be dimensional analysis. Give me a second. I'm going to straighten this out. All right, so this is a packet of notes called, just says the mole. If you can print this off and write on it, that's awesome. Or in-class people will have them, but otherwise just maybe kind of write down some notes as you're going here. All this is going to be on right now is just moles of individual atoms, okay, and maybe some molecules in here we'll see as we go through here, but probably just moles of individual atoms to start with. So remember, 1 mole is that many atoms or molecules. It's also called Avogadro's number. Molar mass, the mass of 1 mole of an element. So for example, carbon is 12 grams. Sulfur is 32, so looking on the periodic table for those as we're doing them. I'm going to kind of just pick out some problems here. So again, I would do these always as dimensional analysis. So first thing is I always start with the number they give me. So 2.5, and I write down the label. You can just put MOL for moles. So remember your rules with dimensional analysis. Whatever label is up here always goes down here. So just my label. So I'm putting mole down there. There's 2 things a mole is equal to. 2 things a mole is equal to. So I have 2 things I can put in here. So whenever I write these spots, I always write the word 1 mole either on top or bottom. So I'm writing my conversions. Either the word 1 mole will be on bottom or it'll be on top. In this case, it's on bottom because my labels have to cancel across from each other. So 2 things a mole is equal to. I can put the mass in grams from the periodic table on there for how much a mole weighs for this individual element. Or I can put Avogadro's number of atoms up here. So I have 2 choices. The grams off the periodic table or 6.02 times 10 to the 23rd. Well, in this case, it's asking how many atoms. So we're going to write 1 mole equals 6.02 times 10 to the 23rd atoms. And you can just put an A for atoms or AT or whatever you want to do for a label. So we're multiplying 2.5 times Avogadro's number. 2.5 times Avogadro's number. I'm going to show you something here real quick. All right. One of the things you got to be able to do is put this in your calculator, and it's a little bit hard. So when I'm putting 6.02 in the calculator, Avogadro's number, I'll put in 6.02. Now in this calculator, there's a little EXP button. So I don't push times, I don't push 10. I just push in the EXP button. Sorry, that's hard to see. And I put in the 23. Okay, so that means 6.02 times 10 to the 23rd power. That is Avogadro's number. So if I was doing this, I'm taking that times 2.5. So if I push times 2.5, it gives me this answer. Okay, which means 1.505, usually just put 1 decimal place, times 10 to the 24th power. It does not mean 1.505 to the 24th power. It means 1.505 times 10 to the 24th. Huge difference there. Okay, that's a huge number. Let me show you a different calculator. If you have a big calculator, it's probably a little different than this one, but if you have a big calculator or other calculators, you're always looking for this double E button right here, that double E. It might be a second function on this big calculator for you guys. It might be above this, but you're looking for a double E button. So if I'm typing in Avogadro's number here, I would type in 6.02. I hit that double E button, which means times 10. So when you see this, 6.02E, that means 6.02 times 10. That means 6.02 times 10 to the 23rd power. So for this problem, I was multiplying that times 2.5. So times 2.5. So I did Avogadro's number times 2.5. Notice it says 1.05, excuse me, 1.505 E24. That means times 10 to the 24th power. So figuring out how to use your calculator is kind of a key here. All right. I'm going to skip these next 2 because it gets into molecules. I don't want to do that quite yet. I'll do some of these. Here's number 5. So we have this many atoms of aluminum. So I start with that number, 5.75 times 10 to the 24th atoms. So nothing goes underneath that ever. Remember, whatever label's here comes down over here. So that's going to be atoms over here. And I always write the word 1 mole in one of these spots. Well, I can't write 1 mole down here, the word 1 mole, because atom's already there. So my 1 mole goes right there. Again, two things a mole is equal to: Avogadro's number of atoms, or the grams off the periodic table for aluminum, in this case. Well, it's giving us atoms, so we got to use Avogadro's number down here, 6.02 times 10 to the 23rd. Now this is 10 to the 24th, so this is a bigger number than that, so our answer should be a little bit bigger than 1. Okay, it is asking for moles, I'm asking for grams. So this label will cancel. We're left with moles right there. So we're taking this number divided by this number. And we do that, we get about 9.5 moles of aluminum. So that would mean here's a mole of aluminum, which has this many atoms in it. Well, if I had that many atoms, it'd be about 9.5 of these, 10 of these. All right. Going on. How many moles are in 25.5 grams of silver? So we start with the number they give us, 25.5 grams of silver. Again, whatever label is here comes down here, grams of silver. And I always write the word 1 mole in one of these spots. So I'm going to write the word 1 mole up here. Remember, these two things are equal. So I got to figure out how many grams of silver there are in a mole. Well, that is not 6.02 times 10 to the 23rd. The grams would be off the periodic table. So I look up silver in the periodic table, and its mass is 107.8, so I'll round out to 108. Whole number's fine. A mole of silver is 108 grams. Well, we have 25.5 grams, way less than 108 grams, so it's going to be less than a mole. 25.5 divided by 108, make sure your labels cancel. Right there. So that divided by that is going to be a couple of decimal places are good, 0.24 moles of silver. One thing I would tell you, all these problems we've done so far, either starting with moles or finishing with moles. Whenever you start and finish with moles, it's a one-step conversion. You have one conversion. If you start with moles or finish with moles, it's a one-step conversion. If you're not starting with the word mole or finishing with the word mole, it's going to be a two-step conversion. Okay, so I'll pick out a couple more here. This one, notice we're starting with moles, going into grams. That's going to be a one-step conversion because you're starting with moles. So 3.57 moles of aluminum. This is moles, so moles comes down here. That's going to be my 1 mole. Remember, you're always writing the word 1 mole in one of those spots. And I know we're going to grams because it's asking you for grams. Well, this is not Avogadro's number then. We're looking at the periodic table. Aluminum is 27 grams per mole of aluminum. So 3.57 moles times 27 grams for each mole. Multiplying across there, 96.4 grams of aluminum would be 3.57 moles. All right, a couple more problems. Look at these last two. So first thing, this is going from grams to atoms. Notice the word mole is not in the question. That means we're going to use a two-step process to get there. So start with the number they give you, 55.2 grams of lithium. Whatever labels here comes down here, so that's grams of lithium. Make sure you know what it's grams of. That means I'm writing the word 1 mole up on top. So we always write the word 1 mole in one spot or the other. So we got to figure out how many grams of lithium are there in a mole. That is not Avogadro's number. Grams comes off the periodic table. So we look up lithium in the periodic table. Lithium is 7 grams. It's atomic mass. So we have way more than a mole here. 55.2 divided by 7, we tell how many moles we have. That cancels with that. But the question is not asking for moles, it's asking for actual number of atoms. So we need to finish with the label atoms. Going here. 1 mole is my label there, so mole comes down here. Again, I'm still writing 1 mole. My other conversion is the number of atoms in a mole. I know 1 mole is this many grams for lithium, and 1 mole is then Avogadro's number of atoms, 6.02 times 10 to the 23rd atoms. So this is a two-step conversion. Notice The word mole and mole cancels. So I'm taking 55.2 times Avogadro's number divided by 7. And you get about 4.7 times 10 to the 24th. Whenever it is atoms, it's going to be a big number. 4.7 times 10 to the 24th atoms. Last question on here. What is the mass? That means we're trying to get grams. Mass is grams of this many atoms. So we're going from atoms to grams. Again, we're not starting with the word mole or finishing with the word mole. We're going to use the word mole in our conversions, but if you're starting with mole or finishing with mole, it's going to be a one-stepper. Grams to atoms or atoms to grams is going to be a two-stepper. So we're going to say we have 1 times 10 to the 24th atoms of manganese. So I know my label here is atoms, so I need atoms down here. That means I'm writing the word 1 mole up on here. Well, 1 mole is Avogadro's number of atoms, so 6.02 times 10 to the 23rd atoms. So I'm taking this divided by that. It gets me into moles. But I want to get to grams, trying to finish with grams. So moles here, the word 1 mole goes down here. Figure out how many grams manganese is for a mole. So look in the periodic table. Manganese is 55 grams per mole of manganese. So divide by Avogadro's number and multiply by that. Starting with this number, type that in your calculator. Multiply times 55, divided by 6.02 times 10 to the 23rd. Will tell you how many grams you have. And it's about 91.4 grams. All right, there's all our conversions for right now. Make another video on molecules here at some point in time.